And I'm like, giant fish. And
What was it?
It was a Goliath grouper.
Oh, I've seen those things before. They're enormous.
Size of a cow. It's like
hundreds and hundreds of pounds, right?
Yeah.
Oh my God.
In a recent episode of his podcast, Joe Rogan finally confirmed what the Navy saw while diving in the ocean, revealing a discovery both thrilling and unnerving. Below the surface of our expansive oceans lies a world largely unknown to us, covering the majority of Earth yet less probed than the void of space. Joe Rogan discussed these underwater mysteries, capturing the attention of his audience. What did he reveal about the secrets lurking in our ocean's depths? Could this new knowledge redefine our understanding of life on Earth? Join us as we dive deep to uncover these mysteries. The unexplored ocean. Covering over 70% of our planet, the ocean is a huge, mysterious expanse that we know surprisingly little about. Despite its size, humans have explored less than 5% of the ocean's depths. The sea holds secrets that could alter our understanding of life on Earth, yet we have barely scratched the surface of this immense frontier. The diversity of marine life in the ocean ranges from the smallest plankton to the largest mammals, like the majestic blue whale. Every new expedition potentially unveils previously unknown species, deepening our understanding of marine biology and evolution. The ocean is more than just a home to familiar species. It is also home to bizarre creatures adapted to extreme underwater conditions. These include life forms that thrive in complete darkness and under crushing pressures, where human access is limited. Marine researchers regularly discover extraordinary creatures in the deep sea. For example, they have found creatures that can live in total darkness and handle the intense pressure of deep waters. These findings include bizarre deep-sea creatures adapted to their harsh environments and vibrant coral ecosystems teeming with life. And now, Joe Rogan finally confirmed what the Navy saw while in the ocean. The ocean's unexplored areas continue to be a critical frontier for scientific exploration. The limited human presence has left many questions unanswered, particularly regarding the deep sea's role in the global ecosystem and how its conservation can be achieved. Understanding these uncharted waters is essential for future conservation efforts and maintaining the balance of marine ecosystems vital to global health. As we dive deeper into the ocean, each discovery has the potential to provide valuable insights into biological adaptations and evolutionary processes. And now, there has been a renewed focus on the ocean's depths, the ocean's mysteries, and NASA's interest. Joe Rogan recently emphasized on his podcast that NASA is intensifying its exploration of Earth's oceans, focusing particularly on the deep sea regions. This initiative might seem unconventional for an agency predominantly known for space missions, yet the uncharted territories of the ocean provide crucial insights similar to those sought in outer space. In a discussion with Forrest Galante, Rogan also showed a bizarre creature was observed in the ocean, capturing their attention with its long, unusual appendages. As they watched the footage, Rogan exclaimed, "Look at this! Oh, whoa, yeah, that's different. Look at the length of those. What are those things that dangle from it?" Initially puzzled whether to call them tentacles or legs, Rogan noted, "It's like an insect, yeah, that's very bizarre." The creature appeared alien-like, bearing clear bends in its body, floating eerily in the water. Reflecting on its strange form, Rogan remarked, "Like when you see that thing underwater floating around like that, looks like an alien totally." The size of the creature also astounded them, with Rogan questioning, "It's huge, it's nuts. Didn't they say the tentacles go crazy long? Yeah, they said enormous." This encounter highlights the unexpected and largely unexplored nature of deep-sea life, often revealing fascinating and startling forms. And NASA's engagement with the ocean's depths is motivated by the extreme conditions found there: total darkness, intense pressure, and frigid temperatures, creating an environment as alien to humans as the surface of another planet. By examining these extreme conditions, NASA can develop and refine technologies that may be employed in space exploration. This multidisciplinary approach leverages the ocean as a testing ground for future missions to distant celestial bodies. Central to NASA's underwater exploration is the development and deployment of the Orpheus submersible. This advanced vehicle is engineered to withstand the harsh environments of the ocean's deepest regions, specifically the Hadal Zone within the Pacific Ocean's Ring of Fire. The Hadal Zone, reaching depths generally inaccessible to conventional submersibles, provides a unique challenge and opportunity for testing. Orpheus is constructed to survive immense pressures found at depths exceeding 6,000 meters, where the pressure is nearly 1,000 times greater than at the ocean's surface. The submersible is equipped with state-of-the-art sensors and cameras that facilitate navigation and data collection under such extreme conditions. Moreover, Orpheus's autonomous navigation systems allow it to maneuver through the rugged terrains of the sea floor without direct human control, which is essential in environments that are too complex or dangerous for manned missions. Orpheus also utilizes advanced artificial intelligence to make real-time decisions during its underwater missions. This AI is crucial for navigating the complex and dangerous terrains of the ocean floor where human operation is not feasible. The AI system allows Orpheus to autonomously avoid obstacles and focus its investigative tools on areas of scientific interest, enhancing the efficiency and safety of the missions. Additionally, Orpheus features sophisticated mapping capabilities that enable the creation of detailed 3D maps of the seafloor, uncovering previously unseen geological features. These capabilities are pivotal for oceanic research and simulate conditions that could be encountered on other planets, particularly under the icy crusts of moons like Jupiter's Europa. The integration of AI and autonomous navigation systems in Orpheus is particularly significant for future space missions. These technologies allow the submersible to operate independently, making decisions in real time based on the environmental data it collects. This capability is directly transferable to space exploration vehicles, which must also operate autonomously in environments where direct human control is impossible. Whether navigating the deepest parts of our oceans or the surface of distant planets, the technologies developed for Orpheus are paving the way for future explorations across the most extreme environments on Earth and beyond. Exploring technological marvels, let's now dive into the depths of ocean lore and the other creatures that have sparked legends, historical and mythical sea creatures. The ocean's depths have been a source of intrigue and mystery, inspiring legends of enormous and mythical creatures. Among these, the giant squid stands out, historically feared as the monstrous kraken. This creature was once believed to be capable of dragging whole ships into the abyss, according to sailor tales. These legends depicted the giant squid as a fearsome monster, yet scientific exploration has revealed a creature that is both real and remarkable, though not the ship-destroying beast of lore. The giant squid, scientifically known as Architeuthis dux, can reach impressive lengths, up to 43 feet for females and 33 feet for males. It possesses 8 arms and 2 longer feeding tentacles, all equipped with suction cups lined with sharp serrations, perfect for catching prey. Despite its formidable appearance, the giant squid's behavior and biology are more fascinating than frightening. It represents one of the largest living organisms and showcases the incredible adaptations life can evolve under extreme oceanic conditions. Historically, the giant squid was largely a mystery, known only through washed-up remains or scars found on the bodies of sperm whales, their primary predator. It wasn't until the 21st century that scientists were able to capture live footage of a giant squid in its natural habitat, revealing its true nature and disproving many of the myths surrounding it. Another legendary creature is the sea serpent, reported by sailors and fishermen over the centuries. Descriptions have varied wildly, from snake-like beings with horse-like heads to creatures with manes or fiery eyes. These tales were often dismissed as mariners' myths until the discovery of the oarfish, the world's longest bony fish, which can grow up to 36 feet in length. With its elongated, ribbon-like body and red crest of fins, the oarfish could easily be mistaken for a mythical sea serpent by those unfamiliar with its existence. The mermaid is another mythical figure, often depicted in folklore and art with the upper body of a human and the tail of a fish. These beings were said to lure sailors to their doom or bestow fortunes on the deserving. Historical accounts, like those from explorer Christopher Columbus, described encounters with mermaids, which in hindsight were likely misidentified marine animals such as manatees, known for their gentle nature. But that's not the only mystery. Mysterious and unexplained phenomena. The ocean, with its immense depths and inaccessible regions, is often the backdrop for baffling disappearances and phenomena that have puzzled both experts and the public. One of the most infamous cases is the disappearance of the USS Cyclops in 1918. This massive U.S. Navy collier was en route from Barbados to Baltimore with 306 crew and passengers aboard when it vanished without a trace. No distress signals were sent, and despite extensive search efforts, no wreckage or bodies were ever found. The incident remains the largest non-combat loss of life in U.S. naval history, and is a focal point for theories about the mysterious Bermuda Triangle. Another mysterious event is the case of the MV Joyita. This merchant vessel was found adrift in the South Pacific in 1955, 5 weeks after its disappearance from Apia, Samoa, headed for the Tokelau Islands. The ship was partially submerged, its lifeboats missing, and with no one aboard. The radio was set to an international distress signal frequency, yet no distress calls were reported. Despite the vessel being in a relatively sound state, the absence of the crew and passengers remains an unsolved mystery. Further adding to the deep sea's mystique are the stories of the SS Waratah, often called Australia's Titanic, which vanished in 1909. It was on its second voyage from Durban, South Africa, to Adelaide, Australia, with 211 people aboard when it disappeared off the east coast of South Africa, near the Agulhas Current, an area known for rough seas and strong currents. No trace of the ship was ever found, despite an extensive search. These incidents are not isolated events. They are part of a pattern of mysterious disappearances that occur in the ocean. The Bermuda Triangle, in particular, is a region that has become synonymous with unexplained maritime disasters. Stretching from Miami to Bermuda to Puerto Rico, the triangle is reputed to see compass malfunctions, sudden weather changes, and disappearances of ships and planes in calm seas, phenomena often attributed to extraterrestrial or supernatural causes. While no concrete evidence supports these speculative theories, the triangle remains a hotbed for mystery and exploration. The deep sea's extreme conditions, immense pressure, darkness, and inaccessibility, make recovery missions and thorough investigations nearly impossible, leaving many questions unanswered. Where there's mysteries, there's bound to be conspiracy theories too, and these incidents have generated many conspiracy theories and scientific theories. The ocean's depths are a source of natural mysteries and fertile ground for various conspiracy theories and scientific theories. These range from natural disasters like rogue waves and sudden structural failures to more sensational explanations such as alien abductions or other paranormal activities. Among the more popular conspiracy theories are those involving mythical sea monsters and ancient, undiscovered creatures. These theories often draw parallels with legendary sea creatures like the Kraken, suggesting that such beings could exist in the unexplored parts of the ocean. The fascination with these creatures taps into the deep sea's alien-like environments, which are so different from the terrestrial settings familiar to humans. Scientific explanations for phenomena in areas like the Bermuda Triangle often focus on environmental factors, such as methane hydrates that cause water density to change and potentially sink ships, or rogue waves, which are massive and spontaneous ocean waves. While these explanations provide a more grounded understanding of the mysterious disappearances, they do not always satisfy public curiosity, leading to the persistence of more sensational theories. Moreover, the discovery of dead zones, areas in the ocean with low oxygen levels where marine life cannot survive, provides a scientific basis for some disappearances. These zones can lead to the sudden death of marine organisms, potentially explaining why sometimes entire ecosystems seem to vanish without a trace. In terms of scientific exploration, advancements in underwater technology allow researchers to challenge some of these theories by exploring deeper and in more detail than ever before. For example, sonar technology and deep-sea submersibles enable scientists to map the ocean floor, discover previously unknown marine life, and study geological formations. This scientific research helps demystify some aspects of the ocean, but also often leads to new questions and mysteries. The parallel exploration of space and ocean by agencies like NASA also feeds into the speculative theories linking extraterrestrial life with deep-sea exploration. The conditions in the deep sea are similar to those expected on distant moons and planets, fostering theories that studying these Earth environments could help prepare for encountering extraterrestrial life. As exploration technology improves and more of the ocean is studied scientifically, some theories may be debunked, while others may evolve with new data, perpetuating the cycle of mystery and exploration. Now that we have dived our way into the depths, we look to some of the challenges these underwater worlds face, challenges and threats to marine life. Despite the beauty and diversity of marine ecosystems, they face multiple threats that jeopardize their existence and health. These threats include pollution, overfishing, and various impacts of climate change, such as coral bleaching and ocean acidification. Pollution stands as one of the primary threats to marine environments. Marine debris, especially plastics, accumulates in the oceans, harming marine life that ingests or becomes entangled in it. This pollution affects the surface and reaches the deepest parts of the ocean, where it can have long-lasting adverse effects on marine species and habitats. Overfishing is another significant challenge. It depletes fish stocks faster than they can replenish, leading to a decline in fish populations and disrupting marine food chains. This unsustainable practice affects the targeted fish species and the overall biodiversity of marine ecosystems. Overfishing can lead to the collapse of local fisheries, affecting the livelihoods of communities that rely on fishing. Climate change contributes to further complications, including coral bleaching and ocean acidification. Rising sea temperatures cause coral bleaching, a phenomenon that weakens corals by causing them to expel the algae that live in their tissues and provide them with energy. This affects the corals and the myriad species that depend on coral reefs for shelter and sustenance. Ocean acidification, a direct result of increased carbon dioxide levels in the atmosphere, further threatens marine life. The ocean absorbs some of this carbon dioxide, which reacts with seawater to form carbonic acid, lowering the water's pH. This change in acidity can dissolve the calcium carbonate shells and skeletons of many marine organisms, including shellfish and corals, posing a critical threat to marine ecosystems and the industries that depend on them. Additionally, the discovery and impact of ghost nets and the Great Pacific Garbage Patch represent significant environmental challenges faced by the world's oceans. These issues highlight the detrimental effects of human waste on marine ecosystems and the need for effective management and cleanup initiatives. Ghost nets are fishing nets that have been lost, abandoned, or discarded at sea. They continue to trap fish, mammals, and other marine animals in a process known as ghost fishing. Each year, ghost nets contribute significantly to the deaths of marine animals and pose a threat to underwater habitats. These nets can also cause substantial damage to coral reefs, ensnaring and breaking coral branches, and smothering reef environments critical for biodiversity. The Great Pacific Garbage Patch, another pressing issue, is a vast area in the Pacific Ocean where currents have accumulated large quantities of plastic debris. Estimated to cover an area twice the size of Texas, this patch consists predominantly of microplastics and larger pieces of floating plastic waste. The concentration of plastics poses severe risks to marine life, including ingestion and entanglement, disrupting the food chain and affecting the health of aquatic organisms. The impact of human activities on marine ecosystems highlights the importance of addressing these threats through improved environmental policies and individual actions. Our ocean's health is crucial for the survival of countless marine species and the overall health of our planet's climate system. However, with conservation efforts and planning for future explorations, things can become better. Conservation efforts and future explorations. Conservation efforts in the ocean are crucial due to the increasing threats of pollution, overfishing, and the impacts of climate change. These efforts are vital for sustaining marine ecosystems that support biodiversity and provide resources essential for human life. Innovative technologies and strategies are being implemented to monitor and protect these vulnerable environments. One key aspect of ocean conservation is the monitoring of coral reefs, which are among the most diverse and productive ecosystems on the planet. Advanced underwater vehicles equipped with cameras and sensors play a critical role in these efforts. They provide detailed images and data that help scientists assess the health of coral reefs and the impact of environmental stressors like warming waters and acidification. This technology enables timely interventions and the implementation of protective measures to help mitigate damage. Additionally, the use of autonomous underwater vehicles and remotely operated vehicles has become more prevalent in conservation research. These vehicles can dive to extreme depths and operate in harsh conditions, allowing for the exploration of previously inaccessible areas. They collect vital data on marine populations and environmental conditions, which can inform the development of sustainable fishing practices and pollution control strategies. Looking towards future explorations, the advancements in oceanic technology support conservation efforts and pave the way for more sophisticated explorations of the deep sea. The development of submersibles like the Orpheus, which can withstand the extreme pressures and darkness of the ocean's deepest parts, opens up new possibilities for exploring these unknown regions. Future explorations aim to map the seafloor more comprehensively, discover new marine species, and study underwater geological processes in greater detail. These explorations are essential for enhancing our understanding of the Earth's geological history and the role of oceans in the global ecosystem. Moreover, understanding the adaptive mechanisms of deep-sea creatures can provide insights into how life might survive in extreme conditions, which is pertinent for astrobiological studies of other planets. In addition to mechanical cleanup, there are also efforts to track and recover ghost nets. Technologies such as GPS tracking and marking systems are being explored to prevent nets from being lost and to facilitate their recovery if they are lost. Education and regulation play critical roles too, by informing fishery practices and reducing the likelihood of nets being discarded. Moreover, public awareness campaigns and international cooperation are crucial for tackling these issues. By highlighting the consequences of ocean pollution, these campaigns encourage more sustainable practices among industries and consumers alike. International agreements and regulations aim to standardize and enforce measures that prevent waste from entering the oceans in the first place. Addressing these challenges involves both prevention and active cleanup efforts. Various international organizations and coalitions are working to mitigate the impact of marine debris. Efforts include the deployment of cleanup devices that can collect and remove plastics from the ocean. One notable initiative is the Ocean Cleanup, a project that employs barrier systems to concentrate and extract plastic waste from the water. The push for deeper and more extensive ocean exploration also involves preparing for the challenges posed by the deep sea's harsh environments. Continued technological advancements will be crucial for ensuring the safety and success of these missions. Innovations in materials, science, robotics, and artificial intelligence will likely play significant roles in shaping the future of oceanic exploration. As we talk about the deep sea and its mysteries, it raises a curious question. What historic venture first mapped the unknown of the ocean's depths? The birth of deep-sea exploration, the HMS Challenger expedition, which took place from 1872 to 1876, is recognized as the foundational event in the field of oceanography. This British Royal Navy ship was outfitted with specialized equipment to carry out deep-sea exploration, marking the first dedicated scientific expedition to systematically study the ocean floor. The expedition covered nearly 70,000 nautical miles, traversing the Atlantic, Pacific, and Indian Oceans. Utilizing the early version of sounding equipment and dredging tools, the Challenger was able to take numerous deep-sea soundings, collect biological and geological samples from the ocean floor, and measure ocean temperatures at various depths. One of the most significant achievements of the Challenger expedition was the depth measurements, which led to the discovery of the deepest part of the ocean at that time, the Challenger Deep in the Mariana Trench. Named after the ship, this deepest known point in the Earth's seabed hydrosphere highlighted the scale and depth of the oceans, far surpassing previous estimates. The scientific crew on board, led by scientists like Charles Wyville Thompson and John Murray, collected over 4,000 new species of marine life, vastly expanding the known biodiversity of the ocean. These findings were pivotal, revealing that life could exist at much greater depths than previously thought, and in environments considered too harsh for biological activity. Additionally, the expedition made significant geological discoveries, including the mapping of global ocean basins and establishing the nature of oceanic sediment. This extensive collection of data laid the groundwork for the science of oceanography, transforming it from a field filled with speculation to one based on empirical data and systematic study. The legacy of the HMS Challenger expedition is monumental, setting the standards for future oceanographic research and deep-sea exploration. Its methodology and breadth of data collection served as a model for future scientific expeditions and significantly contributed to our understanding of marine science and the global marine environment. And it has only led to more and more explorations, and not by scientists and marine biologists alone. The Mariana Trench Exploration. In 2012, filmmaker and explorer James Cameron took a historic solo journey to the Challenger Deep. This marked one of the most significant human achievements in deep-sea exploration. Using the Deep-Sea Challenger, a submersible engineered specifically for the journey, Cameron descended approximately 35,787 feet beneath the ocean's surface. The submersible was a marvel of engineering, equipped with high-tech cameras and scientific instruments designed to withstand the immense pressure found at such depths, more than 1,000 times the standard atmospheric pressure at sea level. The Deep-Sea Challenger took about 2 hours and 36 minutes to reach the ocean floor, where Cameron spent roughly 3 hours collecting samples and recording the first high-resolution images of this uncharted territory. The data collected included video and soil samples, which have been invaluable for scientific research. The imagery captured during the dive revealed a desolate landscape, largely devoid of life, yet important for understanding the geology and low-oxygen ecosystems of deep-sea environments. Cameron's expedition was about reaching the deepest point in the ocean and testing new technologies in submersible design and deep-sea exploration. The Deep-Sea Challenger's systems and materials had to be engineered to cope with the extraordinary conditions of the deep ocean, which offered insights that could aid future designs of submersible vehicles, especially for scientific and research purposes. James Cameron's dive to the Challenger Deep is a significant milestone in ocean exploration, contributing to our scientific knowledge and inspiring future explorations into other unknown parts of the marine world. All these collaborations have really shaped deep-sea exploration. Project Famous. Project Famous, which stands for French-American Mid-Ocean Undersea Study, was a groundbreaking deep-sea exploration conducted in the early 1970s that focused on the mid-ocean ridge, particularly the Atlantic's Rift Valley. This initiative marked one of the first major collaborative efforts between French and American scientists, using manned submersibles to study the dynamics of plate tectonics directly on the ocean floor. The project utilized submersibles such as Alvin from the United States and Cyana from France. These submersibles allowed scientists to dive deep into the Rift Valley of the mid-ocean ridge, offering unprecedented access to one of the Earth's most fundamental geological features. The primary goal was to observe and document the process of seafloor spreading, a process central to the theory of plate tectonics that explains the movement of the Earth's continents over geological time. During these missions, scientists collected rock samples directly from the mid-ocean ridge and observed firsthand the formation of new oceanic crust. They also witnessed hydrothermal vents and various forms of life that thrive in these extreme conditions, supported by the Earth's geothermal energy rather than sunlight. This direct observation provided critical data that confirmed several aspects of the then-recent theory of plate tectonics and opened new questions about the interactions between geological activity and oceanic ecosystems. Project Famous significantly advanced the scientific community's understanding of the dynamic processes shaping our planet. By directly exploring the mid-ocean ridge, scientists gained insights into the complex interplay of geological and biological processes that define the ocean's depths. As the expeditions rise, modern technologies reshape our understanding of the ocean floor and how they are being explored. Seabed 2030 Project. Launched in 2017, the Seabed 2030 Project is an ambitious global initiative aimed at mapping the entire ocean floor by the year 2030. This project represents a significant technological leap in oceanography, utilizing advanced multi-beam sonar systems to capture detailed images of the seabed. These efforts are critical for enhancing our understanding of marine environments and aiding in the conservation of oceanic ecosystems. Multi-beam sonar technology is at the heart of the Seabed 2030 project. Unlike traditional sonar, which emits a single sound pulse downward, multi-beam sonar sends out multiple simultaneous beams across a wide arc. This allows for much more comprehensive coverage and detailed mapping of the ocean floor. Each beam bounces back to the receiver on the ship, providing data that is then used to create precise topographical maps of the seabed. These detailed maps are crucial for several reasons. First, they help scientists identify and study underwater features such as mountains, trenches, and ecosystems that were previously unknown. By understanding the physical structure of the seabed, researchers can better predict ocean circulation patterns and their effects on climate and weather. Moreover, accurate maps of the ocean floor are essential for navigation and laying submarine cables. They also play a key role in resource management, allowing for the responsible extraction of resources like oil, gas, and minerals. Additionally, understanding the layout of the seabed helps in disaster preparedness, particularly in predicting tsunami impacts and locating wreckage from shipwrecks or airplane crashes. Seabed 2030 also aims to enhance biodiversity conservation. With better maps, conservationists can identify vulnerable marine habitats and implement more effective protection measures. For instance, knowing the locations of coral reefs and seagrass beds helps in setting up marine protected areas and managing human activities that could impact these ecosystems. The project is a collaborative effort involving various organizations, including the Nippon Foundation and the General Bathymetric Chart of the Oceans. These groups work together with governments, companies, and academic institutions around the world to gather and share bathymetric data. Their goal is to map the ocean floor and make this information freely available to the public and researchers, promoting greater global cooperation in ocean science. By deploying sophisticated multi-beam sonar technology, the project seeks to illuminate the mysteries of the deep, providing valuable data that can improve scientific research, navigation, and environmental management. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable.